Hi everyone, my name is Christy and my partner is Shinji Yao. Our project is Touch, Directory Optimization for scoring a goal. Ooh, that's not good. Right, there we go. We have our leg right here and the ball, and if we zoom out a little bit we can see a net back here. Sorry, there we go. So we have 3 joints on the leg: the hip, the knee, and the ankle. Our optimization has 2 phases. First, there's a random pass that's chosen that's viable for the leg, and that pass comes in. Then the leg collides with the ball, and the shot goes back out. I think like most of our work was in setting up these constraints and ensuring that everything held. So for example, we don't want the foot to penetrate the ground like it's doing right now. We want the joints to respect their constraints, so we don't want like hyperextension of the knee, for example. We want manipulator equations and implicit Euler integration to hold. At the end of the trajectory, we want the ball to be inside the net. We want the impulsive collision to hold. The angular impulse on the ball should equal out the angular impulse on the leg, and the collision should be sort of clean. Like at the time of collision, the ball should be tangent to the top edge of the foot. It should be on the front part of the foot, so that it's not also colliding with the shin, creating a more complex collision. Yeah, and then we wanted to obey that initialization constraint where it starts with the chosen exposition. It starts on the ground and follows the angle of the pass that we chose for it. Yeah, then as far as costs go, we have costs on all of the actuators, and we have costs on the final state of the leg. So we want the leg to sort of come back to its initial position where the leg is fully straight and the foot is flat on the ground. And now we can look at some example trajectories. This seems to be a result of the actuator costs. We see the leg have some incredible touch, so it has these very smooth tap-ins where it just barely sets itself in position and has the ball sort of ricochet off. And it can do this for a couple reasons. The shot coming in isn't that strong. The pass coming in isn't that strong. The leg is quite a bit heavier than the ball, so it can just sort of, set itself up and have the ball bounce off. There's another trajectory. We see that in each example, the incoming pass has a different angle and a different starting point, but they all are sort of in the vicinity of the leg, and the leg finds a way to hit the ball properly. One more example. And yeah, so some modifications we might make is reduce the actuator cost, so we see some more powerful shots. Like a complementary change to that would be adding a cost for the time it takes the ball to get into the goal, so that we see some more powerful shots. We could also increase the power of the incoming pass, and then also make add some constraints to ensure that the ball is definitely coming in from the front of the goal. Here it seems sort of unclear whether it's hitting the goalpost or maybe even slightly coming in from above the net. So we don't have a constraint for that yet, but that's a simple fix. And then let's see one final trajectory. Alright, thank you.